Hello, can you hear me? Just a second. Can you write me here? Can you hear me?
Yes, I can.
You can hear me on WhatsApp also. I cannot hear you. Okay, all right. Shall we start it? Okay. So let us take one example to understand linearly independent or dependent vector. For example, let V1 2 2 1 and V2 having -4 6 5 and V3 have 1 0 0. Now let us form the linear combination along with alpha 1, alpha 2, alpha 3. 1 0 0 is equal to have the null vector also. Now let us form the linear combination 2 alpha 1 minus 4 alpha 2 plus alpha 3. 2 alpha 1 plus 6 alpha 2 plus 0 alpha 3 and alpha 1 plus 5 alpha 2 plus 0 alpha 3 is equal to 0 0 0 means null vector. Now we can compare each this equation with this. We can form the equations. Are you getting this point?
Ma'am, can you
Means
hear me?
this. Yes, I can hear you now. Yeah.
Why are we not doing the previous example, ma'am? Was it because it was like four
Sure, sure.
terms?
Let me check it again. Actually, that's open. Yeah, we do previous also.
Okay.
Okay, we'll do further.
But in the previous one, there are uh, four
Actually, there was some.
equations.
Yeah, sure, sure. Actually, in previous one, just erase the whiteboard. So just open this. So we are doing this. So shall we do the previous one?
No, we
Just
can
I'm
continue.
opening.
I just wanted to know if there's any reason why we're
Okay, we
not
can
doing
use any one of them. Okay.
it. Okay.
So shall open that?
Continue with this, ma'am.
Okay, all right. We can do any one of them. Even you can give me also anyone.
Okay.
So now, uh, let us equate to form equations. To okay, I have just I'm just clicking that to write on next page. Just give me a moment. So 2 alpha 1 minus 4 alpha 2 plus alpha 3 is equal to 0 and 2 alpha 1 again and plus 6 alpha 2 is equal to 0 and alpha 1 plus 5 alpha 2 is equal to 0. Now let us solve first of all for any two variables. Okay, and we can just subtract, like take equation 1 2 and 3. So just if you subtract equation 3 from 2, what will you get? Obviously you will get C or 2 alpha 1 plus 6 alpha 2 minus alpha 1 and minus 5 alpha 2 gives 0. And here we have alpha 1 and plus alpha 2 is equal to 0 and alpha 1 is equal to minus alpha 2. and we can put in any equation to find another values. So let us find. So let us put this value in first equation. Okay. So let's do it. Alpha 1, and instead of alpha 1 we can take minus alpha 2 also. Let us put it. So 2 instead of alpha 1 we are putting here alpha 2 minus 4 alpha 2 here, and plus alpha 3 is equal to 0. So here we have minus 2 alpha 2 minus 4 alpha 2 plus alpha 3 is equal to 0, and minus 6 alpha 2 plus alpha 3 is equal to 0, and alpha 3 is equal to 6 times of alpha 2. Okay. So we can now put in any equation to get out. So let us means in first in a stage of alpha 1 we are putting here minus alpha 2 minus 4 alpha 2, and in a state of 3 alpha 3 let us put this 6 times of alpha 2, 0. So obviously we have means when we have 0, just a second, minus alpha 2 minus 4, they are, yes, and here instead of alpha 3 we are taking 6 alpha 2. So obviously from here we are getting alpha 2 0. Are you getting this
Yes.
point?
Yes,
So
ma'am.
obviously all of values will be 0. So we can say given vectors are linearly independent. Okay?
Okay. Okay, ma'am.
Or you
Ma'am,
can
and
form
I have a doubt.
yes, ask. Your voice is very slow, so you can ask me, or ask me. Okay, previous examples you want? Okay, we'll do. Sure.
Ma'am, but
I'm
in
just
the previous
opening.
example,
Yeah.
there are four equations and only three unknowns. And that's not possible, right?
Let me check it. Just a second. I'm just opening that example. Which, okay, okay. You are giving the methods. Okay. Determine in your question if the following sets are linearly independent or dependent, if they form a basis of Rn where another, okay. So, to understand this basis and dimension, first of all, means we can check either they are linearly dependent or dependent. But about basis and dimension, we'll do this topic first. If you want to do these questions, let us first do this topic first, basis,
Yes,
okay,
ma'am.
and then dimension, and Leo. Then we
Yes,
can
ma'am.
linearly independent or dependent. We can show in this way as we have done this example.
Okay.
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 So shall we do now first basis,
Yes, ma'am.
basis and dimension? Let us do, and after that we'll do this entire question, all of these parts.
Okay.
Okay. So if you want to ask, like in previous, if we have having the four elements, means in vector, so we'll get a known square matrix in that form. Okay,
What does
or
that
non.
mean?
Yeah. So first of all, we need to reduce that into square one. After that, we can find.
Okay.
Okay. Later, I'll explain you whenever you need it. I'll explain you previous examples also. Example that we were doing that. So now, shall I do that one or shall we do the next topic basis?
Let's do bases. I think I understood what you're trying to say, ma'am.
Okay, all right. So topic is basis of a vector space. And before that, we need to understand span.
Okay.
Okay. So let us first do span also. So to understand basis, first of all, let us understand span of a vector space. After that, we'll do basis.
Okay.
The set of all linear combinations of the vectors in vector space is said to be span of the vector space. You got it?
Yes,
We
ma'am.
set
In
of
theory.
all linear combination. Okay, you know linear combination. The set of all linear combination of the vectors in vector space is said to be span of the vector space.
That's if we are taking different vector, if we're taking different alphas and different combinations of those vectors, then it's a span.
Yes, obviously, different vector. Yes, linear combination. Obviously, because we'll have all in all linear combination. Obviously, we'll have different for different vectors.
Okay.
Okay. So set of these all is said to be span of that vector space. Got it?
Say, ma'am, for example, there's vector 1, vector 2, vector 3, vector 4.
Yeah. For example,
There,
as we have formed that, like we have formed R as a
haha.
linear combination. Okay. So having R1, R2, and up to Rn. You remember R we have done for linear combination?
Yeah, yes, ma'am.
Yes. So set of all of these linear combination is said to be span. Okay. So in a span, obviously we'll take linear combination, not vectors. Okay. Linear combination of vectors we'll take.
Okay,
Got it?
got it.
So we can express this span as, so if S is a set having vectors v1, v2, and up to vn is set of vector, then the span of S can be defined as span S is equal to alpha 1 v1 plus alpha 2 v2 plus alpha 3 v3 and up to um, alpha n vn, where this alpha I belongs to a set of real number scalars, the set of which is the set of all linear combination, sorry, linear combination of vectors in S. Got it?
Yes, ma'am.
You got it now?
Yes, ma'am.
Okay. All right. Now let us do basis. Just a second. Hello. Yeah, are you saying something?
Ma'am, I sent you one message. Can you read it and tell me if it's correct? all note
Yes,
that.
exactly. Yes.
Okay. Ma'am, but I have another doubt.
Okay, you can message me because your voice is very slow, so not mean I cannot hear properly. Sometime I can hear clearly, and sometime some words leaking. Yes, for linearly independent, obviously scalar must be zero.
Okay, ma'am.
Okay.
Let's continue, ma'am.
Okay. 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 Let us do now basis. So what is basis? A basis is a subspace, is a set of vectors in a span. Those are linearly independent, or we can understand as, span has a all linear combination. Okay, but in basis we have only those linear combination which are linearly independent. Are you getting this point?
Yes, ma'am.
Yeah. So we can express a basis of a subspace. Subspace, why we are taking, or you can say a vector space, the set of vectors that span the vector space and is linearly independent. Means we have here these vectors. Okay, they form span. Okay, and in sorry, and in span we have all the linear combination, but in basis we have only those linear combination in which vectors are linearly independent. Got it?
Yes, ma'am.
Okay. And number of vectors or number of means set in this basis is known as dimension. Okay. So I'm just writing you, and we'll take example.
I can't see if you're writing, ma'am.
Pardon?
Are you writing something?
Can you see the whiteboard?
There's nothing written on it.
Just a second. I'm just resharing you again. Just a second. I'm just resharing you. Can you see now? Can you
Yes,
see
ma'am.
now?
Yes, ma'am.
Okay, all right. So let us understand basis. Let S having the vectors like v1, v2, v3, and up to vn be a set of vectors. And as a set of vectors of vector space V. V and S is subset of V also. Then S is called basis of V if S span V means S forms span also, span V, or it this can be expressed as span of S that is equal to V. Okay, me all of those linear combination from vector space is equal to vector space. Are you getting this point? And
Yes.
one another point we have, and S is linearly independent. It is must, okay, to be a basis. Okay, let us do one example. And one more node we have. uh, First, phi is the basis for this null vector. And next point, the standard basis for R. We can express them as I, J, K in this form, like I can be expressed as I is equal to having this form 1 0 0, and J can be expressed as 0 1 0, and K having 0 0 1. Are you getting? So do you have any question in your, like, do you have related to this topic?
What is dimension?
Sure, sure. Means number of vectors present in S is said to be dimension of that vector space. Okay. Number
Okay.
of vectors in basis, or you can say simply, is called dimension of V. The number of vectors in a basis of V is said to be dimension of V. It is denoted by this symbol DIM of V. You got it?
Okay.
Okay, all right.
Ma'am, can you give me some problems to solve for whether identifying whether it's a vector space and also for this linear independent dependent topic?
Okay, so you want some means questions to solve, right? To for
Yes.
practice?
Yeah, I'll
Okay,
solve it today, tomorrow, and give it to you.
sure, sure. I'll give you. I'll give you. So on WhatsApp, or shall I upload in teachment class?
Anything, ma'am. I will access either.
Okay, so I'll send
Uh,
you.
Ma'am, can
Okay.
we do inner product?
Let me check how long it is because I have next class at 7 p.m. That is why. Let me check it.
Okay.
Otherwise, we'll do tomorrow.
Tomorrow I was thinking we
So
can do.
you'll take regular classes, right? From
Yes,
Monday to
ma'am.
Friday?
Yes, ma'am.
Okay, all right. So shall we do because it has means like four means axioms as vector space. That is why we need to
Okay, then.
prove axioms also. So it will take time at least 15 to 20 minutes.
Okay,
So
ma'am.
shall we do it tomorrow? Is it
Sure.
okay? Okay, all right.